Welcome, my name is Roy Smith and welcome to this second session of Food for Thought, which is now here done in Royal Duyvis Wiener. Today I want to talk to you about the thickness of your chocolate, the rheology of your chocolate. It is an important factor because for sure you need to understand how your chocolate is flowing. You need to know why your chocolate is not or well flowing and what you can do about it. Now, so this is about rheology. This comes from a Greek word, you can forget about it. It's about rhei and flow, it's the knowledge of the flow, rheology. Now, what we normally do for measuring rheology, we have equipment in a lab and we have equipment like a Brookfield or an Anton Paar, where you can measure the thickness of your chocolate. Now, this comes with certain knowledge. You need to know what you're doing in these machines. You need to know which spindles to use. If you go on the internet, you will find all kinds of studies and ways to measure the viscosity. And out of these measurements, you get these kind of curves, which you can then evaluate and give a number to your viscosity. And that's all valid, it's all valuable. But in some cases, not everybody will have equipment like this or the knowledge to do a quick and dirty measurement of your viscosity. And one thing I want to mention, the rheology is important because if you are too coarse or too fine, if there is too much moisture or there's not enough fat in there, it will change your rheology. So by knowing your rheology, you know about your processing, you know about your ingredients. It's possible to save ingredients, it's possible to save on the application. You want to know, for example, the exact amount of chocolate you put on a cookie. The exact amount, not too much, not too little, but just enough. Now, and this is where rheology comes in. From a scientific point of view, now we go to a more hands-on method. And for this, I am here with my colleague, Mr. Dennis Hemelaar. And he can tell us a little bit on a more hands-on, practical system way to see what your chocolate rheology is about.
Thank you, Roy.
Dennis.
So especially in chocolate, we look at two things, namely yield and viscosity. Yield is the power you need to get a product to start flowing. And for viscosity is the power you need to keep it flowing. So we have a very scientific method, which Roy explained already. This gives us all these numbers which most people will not understand. But I have a visual way to show you how viscosity, yield and rheology works.
That's exciting. That's really exciting.
Yes. I will get a plate from our heating cabinet.
Die zit links.
Sorry.
So the way we do this basically is we take a small sample to make sure you have the right amount of sample, so the weight, so you need a scale. Well, everybody will have a scale. You put, in our case, we put 3 samples on just to show you the impact. And it's a really visual method, but also when you do a timer, you can measure just how far the chocolate will flow. And you will see this in a minute, where we have some samples.
We will start with a regular dark chocolate. We have done nothing, particular about it.
What is the fat content?
The fat content is about 32%. There is 0.3% lecithin in there already. I will get back to you later what that exactly is. The first thing for us is the most important. How can we influence viscosity, rheology, yield with processing? So part of the processing is the fineness. We got 2 samples here with the different fineness, a finer sample and a coarser sample.
It shows already on
the top of the lid. It's 20 and 40 microns. So in order to have a good test,
I'll have the 20 micron sample.
We want to have the exact same amount of product on top of the plate in order to have a good measurement. So we stir it up a little bit.
Yep.
And I will start on this side with the coarser product.
Most of the time you can already see it just by steering in it. You already have your visual appearance.
So you're going to do about 5 grams. Alrighty.
There we go.
Good enough. Then Roy can go.
So you see, this is important to have more or less the same amount of chocolate.
Yep, you're there
Up
already.
Here
Yep.
already. And then we put it under an angle.
And then you can see already some differences.
So, and this is about how much time do you allow. So let's say after 10 seconds or 15 seconds in this case, and this is building up your own experience and your own database. So after 15 seconds we can stop, we can mark it, and then we can, very simple, we can see which one is more or less viscous. And in this case,
we got the 40 microns, so the coarser product is less viscous, so you have more flow. The finer product, which is 20 microns, is more viscous, so they have less flow. That already shows us that particle size already gives you a lower viscosity and a higher viscosity and a higher yield value. So
it shows you, and in this case, it's the same chocolate. So knowing this, if you want to have the same viscosity, you need to add fat to the sample, which is finer. So the finer you go has an impact on the use of fat. With the current cocoa butter prices, that's quite, that's quite a bit. Okay, next one.
But we can go to the next one, exactly where you left off with the extra fat. So we have, we will get 2 samples again, 3 samples actually on a diff.
This sounds like we have been practicing this.
I think so too. Yeah. So we got 3 samples, the one I got previously, and I need a plate again.
So again, how much fat was in the standard sample?
So the standard sample, this one has 32% fat.
Okay.
Then we got a sample with 33% fat, and we got a sample with 34% fat.
Okay.
We'll do exactly the same like last time. We just now have 3 samples. So you do the reference first?
Yep, in the middle. It's not zeroing.
Yep,
yes.
it's going. Alrighty.
So, 4.6.
Alright, so we do 4.6, that's fine. I do the 33% on this side.
So then I have the 34%.
34, yes, correct. Almost there.
And we put the plates in the stove to make sure that the surface is also at the same temperature. So that it's not too cold, that it's at the same temperature, 45 or 50 degrees. Can you zero it, please?
Yes, sir.
There we go.
Yep, you can go. Yep, good.
So now we put it back up.
So again, 33 reference, 34% fat. Let's see how we go.
And we time it. So if you do the timer, you mark it with a marker.
Well, we can already see that the reference is starting to fall
down.
behind on the other 2.
And now again we are at 15 seconds, so we mark it.
So
and then you can say, as an estimation, 9 centimeters, 10, 8 or whatever the case is.
Yeah. So we can clearly see the one with the most fat is less viscous because it drops down faster than all the other ones. Again, the reference sample is less viscous because it has the least amount of fat. All right. Well,
do we have more?
We have a lot of more. This was quite the easiest part. So we did the processing, which we can influence as a machine manufacturer. And we have the fat, which we can influence with the recipe. But there are more ingredients. Fat is more a natural ingredient. Now we're going to other ingredients which we learned over the years to use in chocolate. One of those is lecithin. Lecithin is a substance or an ingredient which is delivered from soybeans, sunflower, rapeseed, and this ingredient is used to improve viscosity. Actually, by improving, I mean lower the viscosity.
So lower the viscosity means you can have less fat.
You can have less fat, you have a better flow in your processing line.
So the use of lecithin helps you get the rheology of your chocolate
to the point that
you want to have it without adding the extra amount of fat,
which is more expensive in the whole.
Hence you have the name emulsifier. Okay.
Exactly. So before I go on, there is something we need to know about lecithin. You can only add a certain amount. So we know from experience if you add between 0.2 and 0.7% of your total recipe, you have an improved viscosity.
Yeah.
We also know that something else happens when we put in more than that. Let's see how that goes.
I'm really curious about this because normally you add more, you get a better
viscosity.
Viscosity.
Yeah. So we got another plate.
Yep. Here we go.
Right. Then we keep using the reference sample. Otherwise, I have another one.
Oh, please have another one because I don't know.
Don't worry about it.
This is one of the reasons. One of the things. Always label the jar. Do not label the lid. What I did, because then if you mix up the lids, now I don't know which recipe is the reference. But we have prepared it well. I think we still have a reference sample.
Yep.
So how much is in the reference sample?
So in the reference sample we have 0.3% lecithin. So right about in the middle of the range where normal chocolate producers would use. Then we added 0.3% to another sample to 0.6% lecithin in the total recipe, which is still within the limit from 0.2 to 0.7. And then we've added one where we added 1.3% lecithin in a total recipe. And well, we're curious what that will do
for sure
on the viscosity.
Yep. I'll take the reference again.
Take the reference. You can go from left to right this time.
Okay. And we do again a 5 gram.
A 5 gram.
More or less.
Or 4.6 if you are not capable.
My stable hands, my stable hands will show you.
Yep.
A perfect amount of chocolate.
You went over the line.
Yeah, I know. It's early in the morning, eh? So.
It's okay.
Here we go.
Right. So this is the 0.6%. Yes.
Oop, a bit too much.
No, it's okay.
Yeah.
We had 5.2 almost everywhere.
Okay.
So we put it up again. So the reference, the 0.6, the 1.3% lecithin. And there we go again.
Run, run, run.
So.
And then again, so we wait for now, we are at 10 seconds. It's already and this is the 15 seconds mark. So
we already see something very curious. So the reference, which had a normal amount of lecithin, is dropping way faster than the other two. So even for this recipe, the 0.6% lecithin was probably too much already. Yeah. Now, this one we can clearly see it was too much because it's almost not flowing at all. So this is what lecithin does. For some reason, they increase or of course lower viscosity at a certain amount, but when you start adding more, your product becomes thicker. So it has a reverse effect of what you actually wanted to achieve with lecithin. That's what we see here.
Okay, well, Thank you. These were the samples we prepared, and I think it's clear mainly to have a visual impact which you can standardize in your own way for your own recipe, and work on viscosity. Whether you talk about changing ingredients, changing amount, or the processing, yep, finer or coarser, it will have an impact. And we have much more which we can do here. What's the impact of water, for example? What's the impact of PGPR? But that's for something you can see here with us during one of our trainings we do here.
Yes.
So for now, thank you very much for your attention. I hope it was clear. Should you have any questions, please contact us, and then we'll see you at the next time. Bye-bye.
Right, bye, thank you.